I'm going to walk through how to process the MicaSense RedEdge-P triple data in Metashape. And I had a little bit of trouble getting this to the quality that I was satisfied with. And I'm going to show um, some of the things that I figured out that made the data quality much better. And then maybe I'll show you what the bad ortho looked like, and then what the good ortho looked like. So let's get started on that. So first I'm going to add the photos, and this is the combined files for the triple. And actually, I'm going to add the folder, not the individual photos. That'll be faster. Sample data, combined files for triple. It's a multi-camera system. Calibration images were moved to a separate folder, so it identified the images with the calibration panel and moved them to a separate folder. That's fine. So if I look at the model, the images are there. I could clean it up and eliminate some photos, but I'm not going to do that. How do I uncheck that? Reset selection. Gives it back. So if I wanted to eliminate some, I could do that by highlighting them and then eliminating them, remove images. But this looks pretty good, so I'm just gonna leave it as is. Okay, so the first thing that I'm gonna do is I'm gonna calibrate reflectance, and I'll locate the panels. And panels are located. It brought in reflectance data for the different bands. I'm not sure why it doesn't include some of them. And you can get the values from the panel itself, um, but I don't have the panel, and I'm just going to fill in the missing values with what's inputted for the other values. It's going to be close enough. There we go. All the values are filled. Typically, I don't use the sun sensor. I'm going to use it this time because I ran through this process before and used the sun sensor, and the data turned out better than it did without it. So I'm going to include it this time. It all depends on the lighting conditions of when you capture the data. Typically, if you have an overcast day with very variable cloud thickness, where the intensity of the sunlight is variable across the scene, it's good to use the sun sensor. If it's a sunny day, maybe not use the sun sensor, or even if it's like a cumulus cloudy day where there's like clouds and then sun and then clouds and then sun, it's not good to use the sun sensor. Um, it can make the data look kind of wonky, but I'm going to use it in this instance. So it goes pretty quickly. And then let's see. So the first thing I'm going to do is I'm going to align the photos. This is going to take a while. I'm going to put the accuracy at the highest. And we'll hit go on this. Found oblique cameras without specified capture distance. Continue. And what I think this means is as the drone was flying, it was probably causing the camera not to point nadir, and so some of the images were oblique. And I think that's what caused some of the points to be floating in the sky that I'll show you after the cameras are aligned, or the after the step, and I'll show you how to clean it up. Okay, optimize cameras is done. And what I discovered since I processed the first data set is that um, you need to take a look at the point cloud that was generated from optimized cameras. And if I rotate it, there are all these points. There are all these points that are floating above and below the data set that need to get eliminated. So you can see them here, all these points above and then points below. So it's really messy. So I just need to get this oriented correctly so I can eliminate them. There we go. So we can use this selection tool to grab a bunch of these points. Delete. Now I'll rotate it around and just check, see if there's any other points we can eliminate. Okay, that looks pretty clean. And according to Gemini, it says after you delete these floating points from the sparse cloud, you must click the optimize cameras. If you don't, the software still thinks those bad points are part of its math, even though you deleted the visual points. So we need to optimize the cameras again. And now I'll build the point cloud. And I have it set to ultra high. That gave me a better output than just high. It takes a little bit longer, but it's probably worth it. Point cloud is done. And it comes out really dark. It's done this a couple times before, and I think there's a setting in Metashape that lets you lighten it up, but I haven't looked into how to do that yet. One thing I've noticed, so earlier I just processed the 15 bands and excluded the pangrow band, and I didn't see this much of a gap in the point cloud in the middle, this strip of missing points. So I guess that's a little bit concerning, but I'm going to proceed to generating the DSM anyways and just see how the orthomosaic comes out. So we'll go to workflow, build. They have it as DEM, but it's actually a digital surface model. I put interpolation as extrapolated just because back when I was at MicaSense, that's what they told me to do. So that's what I typically set the interpolation to, is extrapolated, and we'll run that. Usually generates the DSM pretty quickly. And it looks like a DSM. You can see there are some gaps in the middle, so that's probably going to affect the way the ortho looks like. But let's see what the ortho looks like. So we'll go ahead and process the ortho now. Okay, let's see what the ortho mosaic looks like. And in Metashape, to brighten it up, you can click this button and it'll estimate, and then you can apply. Actually looks a little too bright. That's better. That looks pretty good. Yeah, there's some weird stuff going on in the middle where the point cloud was very sparse. So that's a little strange. I didn't get that when I processed without the PanCrow data, which is kind of interesting. I'm going to open up ENVI, and I'm going to take a look at the outputs. Let's see, ENVI. And I'm running on a Mac, so ENVI looks a little weird. Oh shoot, I didn't export the ortho, so let's do that. Export ortho. With PanCrow. Okay. All right. I just got to remember what I named it. Let's X out of here and reopen. Triple cam, triple ortho with PanCrow TIFF. Okay, we'll open that. And I'll hit optimized 2%. That'll brighten it up. In ENVI, it's just going to grab 3 random bands. So it's not showing you an RGB composite, but it's just grabbing 3 random bands. I don't know why I can't minimize the screen. It's probably something going on with X quartz, if that's what you call it. But let me actually lighten this up a little more. I'll go linear 5%. There is a little bit of this like weird fogginess, this like striping going on, but it's not nearly as bad as it was before. Take a look at another band combination. There we go. That's a little bit more visually pleasing. But yeah, overall it looks a lot better. That I think that's what is it? Second step of after you align the cameras, you clean up the point cloud. It gets rid of this like weird anomaly, and I'll just show you what that looks like. I'll open up the one that was not good. Let's see, triple cam ortho bad. I think that was it. So this is the one I didn't clean anything up. And I got these really weird, hang on, I just created a different composite combination. Hope this one's decent. But you can see, yeah, over here, like there were these weird, these really bad bands, like fuzzy bands that were showing up on the data. And there was also some funky stuff going on over on this side where you've got these like rectangular chunks in the data set. And all of that went away when I cleaned it up after um, aligning the cameras in Metashape. So that's my biggest recommendation if you're going to process data, 15 band data, the triple cam data from MicaSense in Metashape, is make sure you clean up the point cloud after what is the step? After aligning photos. So after you align photos, get rid of the points that are floating in above and below the data set. And then after you remove those, make sure you optimize cameras again so that it takes those changes into building the point cloud. So I didn't really want to get into ENVI too much. I'm gonna make another video showing how you can do a little bit of analysis of 15 band data in ENVI, and that'll be the next video that I put on the channel. So thanks for watching.